Discovery of the gravitational light bending of the stars around the Sun in 1919 were really embedded in a very exciting history, and that history connected to Einstein's theory of relativity is also very closely connected to the First World War. There was an astronomer in Potsdam. His name is Erwin Finley-Freundlich, and he was obsessed about trying to prove Einstein's theory of relativity. He was working very closely with Einstein, and already in 1914 he set out to go to observe an eclipse in the Crimea. But that was at the evening of the First World War, and so he was immediately captured and locked away and was not able to do the observations. And in a sense, this was a blessing in disguise, because at that time Einstein's theory of relativity was not yet completely ready, and he still was missing a factor of 2. So his predictions were a factor of 2 off from the real result. 2 years later, 1916, Karl Schwarzschild was actually the first one to solve Einstein's equations very simply. And he did this on the front, in the Russian front, while he was a soldier in the First World War. And Einstein then later basically presented his results in Berlin and said he would never have thought that his equations would have such a simple solution. Now, unfortunately, Karl Schwarzschild died a year later from a disease that he has actually caught at the front. And so we were missing a big genius in astronomy for the rest of the time. But his equations are still what we are basing our current understanding of black holes on. And then Sir Arthur Eddington, at that time he was not yet Sir, he was working at Cambridge. He was a professor at Cambridge at that time. And during the First World War, there was almost no communication between Germany, Einstein, and Cambridge. But Eddington had a private version of the Einstein's theory of relativity. And he used that theory in order to evade becoming a soldier in the First World War, because he convinced the London military that he doesn't have to go to war, but he is preparing a solar eclipse. And so Eddington, right after the First World War, then set out to West Africa, and there was another expedition to Brazil where they observed the light bending, and they exactly measured, or roughly measured, what Einstein had predicted. And I think the most important effect of this measurement was that Einstein all of a sudden became famous like a rock star. And from then on, everybody knew the theory of relativity, and a lot of people were trying to measure it, to prove it. And in the years after, there were many, many different and more accurate measurements that proved the theory of general relativity. 100 years later, gravitational waves were discovered, which was a major prediction of the theory. And then also just last year, the gravitational redshift from the black hole in the galactic center was detected with telescopes at ESO. And so I think this rounds up the 100-year history of the general theory of relativity. When you think about similar events that could happen now or in the future, I cannot help but think about the mess which we are in, our ignorance about dark matter, dark energy, black holes. We don't have a clue yet about what dark matter is, what dark energy is. We know something about black holes. But somehow I have the feeling that we are in a similar situation in 100 years ago, that there has to be something, a new Einstein to come to explain to us how all of that fits together. For me, it's highly speculative, but also highly fascinating to think about whether black holes have something to do with dark matter. And I think we are set up for the next decades to really do fundamental observations in this field.